Welcome everyone to this special educational event for REP members. Thank you for dialing in. I'm Jim DePeso, REP's Policy Director, calling you from the gray skies of Seattle. Research scientist Katharine Hayhoe, who is on the call, has graciously agreed to brief us on the science of climate change. Very briefly, Katharine is a research associate professor at Texas Tech University's Department of Geosciences. Those of you who attended REP's 2007 annual meeting in San Antonio will remember the fascinating presentation she gave on climate science, and much has changed since then. Katharine has written more than 30 peer-reviewed research publications and served as an expert reviewer for the Intergovernmental Panel on Climate Change. Most recently, Katharine and her husband Andrew Farley co-authored A Climate for Change, a book that offers straightforward answers about climate change science. Those of you who RSVP'd received an email with a link to a PDF of Katharine's presentation. If you need to call it up now, the link is www.rep.org/Hayhoe, HAYHOE_climate.pdf. Katharine will go through an approximately 40-minute presentation based on this PDF, and then I will open it up to questions. We have about an hour and 15 minutes total, so we'll have about 30 minutes for Q&A following your presentation. So, Katharine, again, thank you so much for your time, and you may proceed.
Thank you very much, Jim. Well, it's a pleasure to speak to you today through the miracles of modern technology. I hope everybody's had a chance to download the file. It is quite large, so I know that you might be having some problems. So as we go through, I'll just say next when we're going to the next slide, but if you don't have it up in front of you, you'll probably be able to follow what we're talking about just fine. So if you want to go ahead to our slide number 2, what I wanted to start with was just a reminder that climate change is not a distant and far-off thing that is affecting people outside the country. In the U.S., in Alaska, there are a number of native villages built on what used to be permanently frozen ground. But as it warms in Alaska, much more quickly than it is here in the continental U.S., the ground that many of those towns, like the town of Kivalina that we have a picture of here, the ground is melting and crumbling into the ocean. And so, next slide. This just shows some of the efforts that the people in these villages are making to shore up their coasts. But the sad truth is that the first village, the people of Newtok, Alaska, were actually driven from their homes by flooding last April. Villages like Kivalina, which we're looking at here, may be next. So climate change is not an abstract unreality anymore. It is something that is already affecting people right here in the U.S. to the point where there are people who are having to leave their homes and abandon their villages because of climate change. Next. So to start off with, the first question we need to ask is, what is happening to our world? We see all of these things, we hear about them in the news, but what is it that's really happening? So if you go to the next slide, what we have here is we have global temperature measured by the Hubble thermometer all over the world since about 1850. That's when we actually had enough thermometers around the world to get a true global average. Although the oldest thermometer record, the Central England temperature, actually goes back to 1659, which was the English Civil War. So from 1850 until now, we see two things when we look at our global temperature record from thermometers. We see, first of all, that temperatures go up and down from year to year. That's weather. You can have a cold year, you can have a warm year. You know, next year could be colder than this one or warmer. But at the same time, what we see is a steady increase over climate timescales. Climate timescales are decades, typically defined as 30 or more years. And so what we see is that 9 of our last 10 years have actually been the warmest on record. The 2000s was the warmest decade on record, followed by the 1990s and the 1980s before that. Now, even though this looks pretty obvious that temperature is increasing, if you pay attention to what you hear in the news, you probably heard, especially last year, talk about global cooling. That global warming had actually reversed and temperatures were going down. Where on earth did that come from? Well, if you go to the next slide, this shows you where it comes from. 1998 was an abnormally warm year with El Nino. And 2008 was relatively cool with a La Nina event. Now, 2008 was still I think the 10th warmest year on record. But because 1998 was so warm, if you connect the dots from 1998 to 2008, and you ignore everything in between and everything that came before, then you can actually get a line going down. But what this figure shows is the fact that cooling is a myth, because it ignores everything else. And so this is something that we call cherry picking, and every time you hear something in the news or you see something online that just doesn't sound right, I would bet you for many of those things, this is what's going on. People are picking the data points that they like, and they're throwing everything else out, and they're saying, look, this data shows it's actually cooling, when in fact the truth of warming is that we've seen a steady increase. And here it shows the increase since 1960, and in fact it's been increasing since the beginning of the century. Not only that, but if you go to the next slide, what we actually see is that it's increasing faster and faster. Our global temperature trend over 150 years, then over 100, then 50, then 25, is steeper and steeper over time. So global cooling is not happening. Global warming is not slowing down. If anything, it is happening faster and faster. And something we often don't realize is that these increases in air temperatures that we see from thermometers are just the tip of the iceberg. If you go to the next slide, this figure shows the total amount of heat absorbed by the land and the atmosphere compared to the amount of heat absorbed by the ocean since 1950. And what we see is that the ocean has absorbed almost 20 times more heat than the atmosphere and the air. So even though we see this increase in air temperature, it is, like I said, just the tip of the iceberg in terms of how much our planet has heated over the last 50 years. As you'd expect with all these warming temperatures in the ocean and the atmosphere, on the next slide, we get a lot of melting ice. Our sea level is rising, first of all because the water is warmer, and warmer water takes up more space, but it's also warming because all of this ice that we have on our land surfaces, like Greenland, that you're looking at here, is melting faster and faster. Back in 1979, the first satellite observations of Greenland showed that the only areas that melted in Greenland in the summer were along the coasts. But as you can see from the other image from 2007, now in the summer, a lot of Greenland, all the way up into the top parts of it on the south end, are melting during the summer. And as this water melts, it flows into the ocean. Now, there's other ice that we talk about a lot at the poles, next slide, and that is the Arctic sea ice. And the Arctic sea ice is shrinking also. It doesn't contribute to sea level rise because it's already displacing the same amount of water. It's sitting on top of the water already. But what we see is that consistently, year after year, this ice is retreating further and further in the summer. It's raised all kinds of interesting international issues. All of a sudden, countries like Canada and the U.S. and Russia and Denmark, who didn't really care about the Arctic before, have realized that there's a very good chance that the ice is going to be gone within a matter of a couple of decades in the summer. So it's going to open up that area to massive geologic exploration. And so all of a sudden people are fighting over who gets to plant their flag in what part of the Arctic. There's other ice that's melting too. Go ahead to the next slide. These are some of my favorite pictures here. There's a photographer called Gary Brash who documents the effects of climate change around the world with his camera. And what he did about a decade ago was he collected all of the old photos of glaciers that he could find, and then he traveled around the world and tried to stand in the exact same place at the same time of year and take a picture of what those glaciers look like now. So this is a picture of a glacier in Norway, for example, in 1922, and then again in 1992. And as you can see, that glacier has retreated far back up the mountain. The next slide shows a glacier at the opposite end of the world in New Zealand. This is the Franz Josef Glacier in 1939, and then again in 2001. Again, it's receded way back up the valley. The next slide shows a glacier in Africa. There really are glaciers in Africa, but probably not for too long. This is the glacier in 1906, and then again in 1994. And then here in the U.S., if you look at the next slide, we actually have a park called Glacier National Park. When that park was created, it had over 150 glaciers. By 2005, only 27 of those glaciers were remaining. The picture here shows the Shepherd Glacier in 1913 and 2005, and you can see that it's hardly even worthy of being called a glacier anymore. There's just a few strands of snow high on the mountain. The oldest picture that Gary found is the next slide. This is a picture of a glacier in Switzerland. The first picture is from 1859. And what you see is this massive ice sheet spreading down the mountain and throughout the valley. Glaciers were such a threat back in the 1800s that one Swiss village actually went to the Pope and asked the Pope for a special prayer to keep the glacier back. The Pope gave them that prayer, and they've been saying it every year until this past September. And in this past September, as you can see from the other picture, these glaciers have retreated way back up the mountain. So this past September, the people went back to the Pope and they said, we need a different prayer. We want a prayer to keep the glacier. And so the Pope gave them the prayer. But unfortunately, I don't think it's enough. So some places right now are experiencing too much water as the glaciers melt. We see a lot of glacier outburst floods in places like the Himalayas. But conversely, if you go to the next slide, we're also seeing places where they have not enough water. Central Africa is one of those places where they used to be able to count on a couple of wet years and then a couple of dry years, and then a couple of wet years and then back to dry again. But since the 1970s, they have been in a near permanent state of drought, where they do not have adequate moisture. They don't even have regular moisture. It's very, very dry conditions, and it's difficult to grow the food that they need. If you look here in the U.S., the next slide, this is something that might be familiar to anybody who's a gardener. If you're a gardener, you probably have seen these plant hardiness zone maps before. They come on the back of seed packets or on material that comes with plants or trees that you buy. And what they tell you is basically what time of year and you should be planting certain plants and which kind of plants you can grow depending on where you live. Well, the original map was done by the USDA in 1990 using data from the 70s and 80s. And in 2006, the National Arbor Day Foundation redid that map. They redrew it. And if you put your finger on where you live and look to see where it was back in the 1980s versus where it is today, you'll see that nearly every place in the continental U.S. has changed by almost an entire plant hardiness zone. So in other words, Chicago now feels like Carbondale, Illinois did just 25 years ago. Here in Lubbock, we feel like Austin did 25 years ago. We don't have any of the other parts of Austin, just the weather. And so what this shows is it shows you that things are already changing. And if you observe what's going on in your backyard, you have probably seen the very same things. Here where we live, for example, in West Texas, we see these red fire ants that we never used to see because it used to be too cold. A colleague of mine keeps track of when the peach tree in his backyard flowers every year. And it's been flowering weeks and weeks earlier in the year than it used to when he first moved here 30 years ago. I'm originally from Toronto, and I love tulips. And so it was a big deal for me that the tulips would be out for my birthday in April. And growing up, I remember that happened maybe 2 times, that the tulips were out in time for my birthday in April. But now, every time I go back to Toronto, the tulips are out every year. In fact, it's an odd year when you don't get the tulips out in time for my birthday. So we are seeing these changes all around the world, and it's not just around the U.S. If you go to the next slide,